Hello and welcome to lecture series on electrodynamics. Um, we will be doing cylindrical coordinates, and as we discussed, if there is cylindrical symmetry in previous case where we has discussed that if there is a spherical symmetry, then it's better to use the spherical coordinate. And if we have a cylindrical symmetry, then it's better to work with, or it is convenient to work with cylindrical coordinates. So again, our reference is uh, those Cartesian version of coordinate system, and say we have Cartesian coordinate x, y, z. So in cylindrical coordinates, we have cylindrical symmetry. Then we have something like this. So we have a cylinder, and there is a some point at cylinder surface, and this is z-axis. So this is we took point is here somewhere. In Cartesian, we know that it's x, y, z, but in terms of cylindrical coordinates, we use s, v, and z. So z is the same as we have in Cartesian coordinate. So this is the from the z is s. Yes, in some books it's used to be defined in terms of rho, but in this book we the Griffiths use s to avoid the rho with as he is using rho for charge density. So here we are using s. This is s is distance from z to point on the cylinder. So this is s, and so I can express this better. This is s. And again, for z is this distance from the origin. So you can see that for spherical coordinate, in fact, we were taking this r, and we were taking the distance from the origin r. Now we are taking s from the z-axis. So z is the same z. S is the distance from z to the point, and v will be again we on the projection of the point on x, y, z, and phi is the same as phi was in previous case. But yeah, there is a difference in r. So this is again s. So this is, if we draw this, then this will become in terms of s. This is s. This will become, this is phi. Phi angle is on this side, so this side will become s cosine phi, and then this side will become, or either this side will become s sine phi. So this is y and this is x. So we can write our s phi s phi z in terms of x, y, z. So or other way around, x is s sine phi, y is s sine phi, and z is z. So the unit vector again in this case we have s is here, and z is same z upward, and phi will be somewhere here. So we can express again S, P, and Z in terms of unit vector in terms of our coordinate system. Now Cartesian coordinate system, sine phi y, and phi will become minus sine phi x plus sine phi y, and z is same z. So z unit vector will be same unit. So the infinitesimal displacement, again, we can work out in as we did in the previous case. So DLS will be, we are going S. So if this is S, then we can take DS. So it will become DS, S unit vector. In S direction, this is the length element. And in phi direction, the length element will become, we are say moving again phi in upward direction. This is S sine phi, and here if we can see this is S, we are moving up, so this will be S d phi. This is not S sine phi, so this was S, this was S, this is d phi, and then this arc length will become S d phi. So S d phi unit vector, and dz is same dlz, so it will become dz vector. And similarly, the general length element will be dss plus sd phi unit vector plus dz vector. And volume is to multiply all the length elements, so d tau will become sds d phi dz. And for area, again, reference, we have to keep the reference where we are taking the area. Area is on the surface of the cylinder, which is perpendicular to S. If then it will become dl phi dlz S unit vector, and it is sd phi dz S unit vector. Is likewise we can write for d phi dA phi, the area which is perpendicular to phi direction, and it will become dls dlz phi unit vector, and it is ds dz phi unit vector. So the daz will become dls dl phi and z vector, and it will be d sds d phi z unit vector. Similarly, as we talk about our vector derivatives in spherical coordinate, similarly we can express our vector derivative in cylindrical coordinate. So delta t, the gradient will become partial t over partial s unit vector plus 1 over s partial t over partial phi unit vector plus partial t over partial z unit. And similarly, we can write del v, we can write del cross v, and again these formulas are provided in the book. and we don't need to derive them. And you can, they are provided on the book cover, and we don't need to bother about too much about to derive them or to try to memorize them. So this is this much for cylindrical coordinate system. Um, we will continue with next section. Thanks for joining. See you in next lecture. Bye.